Hey everyone, welcome back to 197 Concepts. So in this video, I'm going to discuss with you the Arduino-based water level detector using the water sensor. Okay, so basically, you might have get an idea of what I'm going to discuss in this video or what we are going to design. So in order to check the water level in any tank, I'm going to design a circuit, okay, using Arduino Uno board. Okay, it's not, you cannot say it as a microcontroller because the component that is sitting on the Arduino Uno is the microcontroller. It's Arduino Uno is a board, okay, so that is able to hold the Atmega microcontroller. Okay, so you can see the circuit in front of your screen or on your screen, and the this is you're familiar with this. Let me change the color. It's blue. I need to change it into something much brighter color. Like let's go with the black. It's standard one. This will be much better. Okay. So you are familiar with this. This is the Arduino Uno. Okay. You are familiar with this, and this part as a name here it's defined. This is the water sensor. Okay, so this is the water sensor, and here I'm using LEDs in order to indicate that my 20% less than 20% of the tank is filled, and 20 to 40% of tank is filled, 40 to 60%, 60 to 80, 80 to 90, and greater than 90%. So this is the representation how much water I have in my water tank. Okay, so first of all, you have to know the working principle of this, what we say, the working principle of how this, uh, just a minute. Yeah, gray is visible. Yeah, yeah, it's visible. So first of all, you have to know how this water sensor is going to work. You might be able to see these tracks, right? You are able to see these tracks. So if I keep a point on it, it's going to be erased. So better, I will just explain you like this. These white colored tracks are nothing but these are the copper paths. Okay, these are nothing but the copper paths. So at this end, we will be sending electric current. We will be sending electric current, the power supply, and this is the base of one per transistor. Okay, now basically these lines are connected to a transistor. These lines are connected to a transistor, and when these pins touch the water level, these pins touch the water levels, definitely the as this side of the board, as this part of the sensor is connected to the base of the transistor, this transistor, uh, what it is going to do is it is going to activate the base, which in turn will allow the passage of electrons from the what we say from so this is base, right? So from emitter to collector. Okay, so if you're talking about I believe so these can also be named as gate, source, and drain, but that's in the other part. So here we are talking with the base, emitter, and collector. Okay, now. So that's what I'm trying to say. Whenever the water touches this level, what will happen is it's going to activate the base of the transistor, and as the base is activated, the emitter will allow the passage of electrons towards the collector. Now that current will be recognized by this Arduino board, by this Arduino Uno board, and then it will, based on the intensity of that current, it is going to activate the LED. Okay, so that's the basic working principle. I hope you have understood the basic working principle of the circuit. Now, What I'm going to do is I'm moving towards the code. So take a screenshot or just take a pic of this circuit diagram. So this will be much easier when we go towards the program. So instead of shuffling here and there, you can keep a photo beside you in the same screen. You can keep the photo aside and you can see the program. So this is the program. So I will be the changing color. Okay. So initially what I'm going to do is you have to keep in mind that the sensor pin, okay, this is nothing but your water level sensor pin. This is an analog pin. Okay, it's not a digital pin, it's an analog pin. That's why I have used the analog pin, the very first analog pin A0. It's up to you whether you want to use A0 or A1 or A2, that's up to you. But I have used A0, so that's why I have assigned it towards this A0. And all these pins are nothing but the pins of LEDs to control all the LEDs. So how many LEDs are there? Less than 20%, then 20 to 41, then 40 to 60%, then 60 to 80%, 80 to 90%, and finally greater than 90%. 1, 2, 3, 4, 5, 6. So total 6 LEDs. These 6 LEDs has to be connected to 6 different pins of Arduino Uno board. That's what I'm doing. And this R LED means red LED, Y LED means yellow LED, Y2 LED means yellow LED, that is the second one. Okay, so I'm using two yellow LEDs, two blue LEDs, one green LED. Okay, so B2 LED means the second blue color LED and B LED means first blue colored LED. Okay, we have got the declaration there. So these are global declarations. Whatever I have declared here, all these 7 pins, these are the global declaration. I can use anywhere in the software. Okay, now we have void setup and void loop. So in the setup, what we are going to do is, if you observe here, only all the 7 pins. So sensor pin, LED pin, red LED pin, Y LED pin, yellow LED pin, second yellow LED pin, blue LED pin, second blue LED pin, and green LED pin. What we are doing is we are defining whether it is an output or input pin. Okay, so this is the Arduino. Definitely, I'm going to give the sensor pin from here to here. So definitely, this is the input, and all the 6 pins, all these 6 pins are connected to LEDs. They're showing the output. So those are the output pins. That's what I'm doing. So that's why pin mode, input, sensor pin. Then pin mode, LED is an output. So that's a output pin. All the LEDs are output pins. That's what I have done there. Okay. Now, the very most important part here. When you come for the void loop, the very first thing that I'm going to do is I'm assigning a value, I'm assigning a variable called as value, okay, value to collect the current that is generated by the transistor. Okay, I'm telling the Arduino Uno board to read the current that is generated by the water sensor. So read of sensor pin. So what I'm trying to tell is here, if you go here, so you observe here this A0 pin. Okay, this A0 pin, I'm telling the Arduino Uno to read, to accept the input coming from this particular A0 pin. That's what this that's what this instruction is telling the Arduino Uno board. Now you might ask me, what is analog read? Since I'm getting an analog value, I'm using the analog read command. If I had been getting the digital value here, what I would have written is digital read. Of course, D is small, okay? D is small and A is small here. It's a case sensitive language. Just like digital write that I'm using for LED pins to be high or low, In the same manner, I would be using digital read to accept the data from the digital pins. Okay, as the sensor is able to produce only analog values, that's why I'm using the analog read, and that's the main reason I have connected this what we say my sensor at the analog pin side. Okay, now the next one. See, the sensor is producing the current value in amperes, and I need the output. So the input to the transistor, the input to the microcontroller Arduino board is in amperes, and the output I need is in percentage. Okay. So Arduino, will have some different values. It doesn't know so what is the current. What is the current? Okay. In order to complete this bridge, what I am going to do is, for example, my water sensor is able to generate a value, current value some from 0 to 1023, not amperes, a digital value. When I convert this current into digital form, I assume that my transistor is able to generate a digital value from 0 to 1023. So a total of 1024 steps. Okay, so a total of 1024 steps. Now, this 1024 steps are going to be mapped in the percentage. So, for the initial value is going to be mapped by 0%, and the final value will be mapped as 100%. And the command that I'm going to use for this is map. Okay, map. So, the command is map. First of all, map. What variable you are mapping is the value variable. Okay, initial value of the value variable is 0, and the final value is 1023 of the value variable. So this has to be converted into the percentage. So the initial percentage value is 0, and the final percentage value is 100. Okay, that's what this command is. Okay, so of course here I will get an integer value. Here I will get an integer value, so I'm defining the data type as int. Okay, and after that I have used only the if else if clause. Okay, if and else if clause in order to check the condition, as I need the output for less than 20%. So I'm having six conditions. Okay, for these six conditions, what I'm going to do is I'm going to define separate conditions. For the very first one is if level is greater than 90%. Okay, if the level is greater than 90%, then all the LEDs should be high. Okay, so less than 20. If I'm having 90%, more than 91 or 92% of water in my tank, definitely it's greater than 20%. It's more than 20 to 40. It's more than 40 to 60. It's more than 60 to 80, and it's more than 80 to 90 also, because my value is 92% of water in the tank. That's why all LEDs should be high. Okay, here you can use only if clause also, but the only if clause will give you some errors. Not errors, you won't get the output very much in a good manner. Okay, so that will be a little bit of abruptness in the output. So that's why it's better to use the else if module. Okay, right? So in the second else if, what we are going to do is we are going to keep the levels between, so greater than 90 is completed. So greater than 90 is completed. The next type is 92, sorry, the 80 to 90%. For that, what I am going to consider is, if you observe the circuit diagram, what here you are doing is you are just turning off this one. You are just turning off this LED, and all the other LEDs are turned on. That's what, if you observe here carefully, what we are going to do is we are going to do the same thing. Okay. So yeah, this where is the full screen? Let me try the full screen. Yeah, or else I will go like this. Okay. So the first condition is completed, and if you see here, all the pins are at logic high. All the pins are logic high, other than the topmost one. So green LED. This is the at low position. So you observe the code for 60 and 80. I have done the same thing. Okay, for 60 and 80, I have done the same thing. And for 22, let me delete this strobes. Okay, for 60 to 80, I have done what I have done is I have turned off the first two, the topmost two LEDs, and I have kept on the all other LEDs. Then 40 to 60, the first three LEDs will be turned off and other three LEDs will be on. Then 20 to 40, only first two LEDs will be on, the bottommost, not the top one, the bottommost, and the top four LEDs will be turned off. So I've written the program in the opposite direction. Instead of coming from 0 to 100, I have come from top to bottom. Okay, it's up to you. You can just reverse it also. Okay, just be careful of the conditions, right? So yeah, let us try this program now. So I'm going to copy this, and before trying it, what I'm going to do is I am going to create a folder here. Okay, named as water level. Okay, and now what I'm going to do is I'm going to open Arduino IDE. I'm going to create a new sketch. Okay, so file, new sketch. I'm going to close this one, delete this, and paste the program. Oh, no, it has not copied the program. Okay, I will copy from Notepad. Copy this one and paste here. Right, this is the whole program. So it's better to keep the what we say the pattern. Okay, so it will be easier for understanding. So it's just the representation would be good if you do this. It's not necessary, but by default, when you type the program, it's going to come in this layout. So that's why I'm doing this. So since I've copied it, this is there are no proper spaces. If I had typed it, then I would have got the same layout. Finally, the else part. Okay, that's it. Don't forget to close this parenthesis. Okay, so that's the program. What I'm going to do is initially I'm going to save it before executing anything. I'm just going to save it. I'm going on the desktop, so water level, and here water level. Okay, Yeah, there should be no spaces here. I just need to give an underscore, or I can just keep it like this. So yeah, that's my code. Now I'm going to verify it. I'm going to check if there are any errors, syntax errors. So there are no syntax errors. I am going to export this into the binary format, the hexadecimal format. Okay. Now, since this programming part is complete, what I'm going to do now is I'm going to open Proteus. Okay. So new project, browse, and here on the desktop we have water level. Select the folder, and the project name what I'm going to keep is same, water level. Then I'm not going to change any layout here. I'm just going to click on finish after clicking on next. Okay. And here I'm going to place the components one by one. After going into the component mode, pick devices. First of all, what I need, Arduino Uno. Okay. So there is the circuit diagram. We have other one. I'm trying this one. So it's just the representation difference. Other than that, there is nothing else. Okay. So Arduino Uno placed. Now I need LEDs. So LEDs, there are, let's go with this code. Okay. So two yellow, two blue, one green, and one red. So green and red are one, green and blue are two. So first of all, red LED, red LED, LED red. Yeah, that's the one. And then I need a green LED. So green LED. Then I need yellow LED. I need two of this. So one is enough. And blue LED. Okay. Finally, our water level sensor. Yeah, water sensor. So this won't be available. You have to download this from the website, and from any of the website. You have to download this library file and place it into uh, the library files of Proteus. That's it. I'm selecting it, and one by one I'm placing the components. Yeah, I need a capacitor and an inductor also. Capacitor. So what type of capacitor is that? We have to see it. It's a regular capacitor, and the value is 300 microfarads, so 27 microhenry. Okay, no problem. We will just select the capacitor here, and the inductor value. The inductor, yeah, primitive. So initially, I'm not going to connect the inductor and the capacitor. I'm just going to place the component and connect it. And yeah, we need a variable resistor also. So for that, I'm going to take potentiometer. So one potentiometer will have the values to change like this one. Okay, potentiometer HC. So this is not having, so I don't believe it is useful for us. Let's go with potentiometer HD. I will tell you why. So mirror this and place it here. Place it right here. Because we are going to connect this test pin with this here. Because we are not able to test the sensor, we are not able to generate the sensor values in the virtual world. Because if it is in a real world, we would have dipped this sensor into the water, but here there is no availability of water. That's why what we are doing is we are using a potentiometer to make the object believe or to generate currents from this sensor, from this transistor. It's just maybe mimicking the load of the water that would be present in the real world. Okay, so that's the main thing. So yeah, we have here power and negative, so power supply and the ground. So for that, what I'm going to do is I'm going to in terminals mode, I'm going to select the power, this one, and I'm going to connect it. Along with this, let us drag this a little bit higher, because along with that I need power for this also. Finally, I need a ground. I'm placing the ground here for this also, and I will just drag this line like this. Okay, yeah, I've connected the ground. Now, the sensor pin has to be connected to the A0 pin. I have done that. Okay, and the final part, connecting the LEDs. So, LED blue, let us check the code once, because the very first pin is LED red pin for more than 90%, right? For 90%, all the pins are high. Yeah, you have to go with this. The red pin is connected to pin number 2 of the red LED is connected to pin number 2 of Arduino board. So red LED, rotate it anti-clockwise. No, rotate it 180 degrees. So it is connected to pin number 2. Okay, and yeah, I need a ground here. So just let me place the ground here and like this. That's it. Go back to this and check the program once again. The yellow LED is 3, 4. So two yellow. Let us connect the green LED pin. Okay. So green up to where is the green? So here, rotate in clockwise. No, I should rotate in anti-clockwise. I got the diode 2. So no, we have to go in a sequential manner. Yellow, two yellow LEDs. Anti-clockwise D2, anti-clockwise. Okay. So D2. That's it. Now next are two blue LEDs, I believe. Yeah, 5 and 6, two blue LEDs. And the final is the green LED. So 3 will be connected to this, 4 will be connected to this, 5 will be connected to this, 6 will be connected to this, and finally 7 will be connected to this. Okay, and all these pins will be connected to ground. like this. Okay, so that's a complete connections. Now what I'm going to do is I'm simply double clicking on this because I need to dump the program. So click on browse. So water level, of course, it's there itself. Build Arduino, and hex. Okay, that's it. I will click on OK and I will run the simulation, and we get error. Okay, if you select that, it tells program property not specified for water. Okay, so what is the reason for that is since it is having an IC integrated circuit here. Okay, so even for this also we have a program to dump. So this, when you open here browse, so simply you're just double clicking on this sensor and you're clicking on the browse option. Immediately it will show you where you have saved the folder, where you have saved the project. You should not, your hex file will not be here for the sensor. For the Arduino, your program file, your hexadecimal file will be present here, but for your sensor, you have to go into the C files, okay? C drive, your OS files, the where your Proteus software is installed. So mine is installed in program files 86, Lab Center Electronics, Professional 8, Proteus 8 Professional, Data, and Library. This is the folder where I have dumped all the additional sensors that I need to be displayed in the Proteus. Okay, and if you observe here, I have water sensor.hex. So this file will tell how to simulate the water sensor in as a device, electronic device. Okay, so okay. Now when I run this, so there will be no errors, definitely. But let me check the values. So yeah, that's 0. Up to 50%, there is no value here. If you go above 50, so still no changes in the LED. Okay, so that's because I have directly connected the sensor value. I need a capacitor here. I need a capacitor here. Okay, and an inductor like this. So this is a filter. Okay, this is a filter. What they do is they filter out all the unnecessary currents. Because we are dipping this in the water, there will be some unnecessary currents. So, what we call in the terms of uh, electronics, we call those as noise. Okay. So, in order to remove that noise, what we are going to do is we are going to add a filter here. That is the combination of these two. Now, this supply will be given to the A0 pin of our Arduino Uno. Now, if you run this, see, I have got some value here, but even when I reduce this, the yeah, this is the problem. So I've reduced the resistance here. Okay, when I'm increasing the resistance, I'm telling that that much water, that much level of water is getting reduced in my tank. Okay, or is it the opposite way? If 100% means I'm having 100% of water in my tank. Yeah. If this rheostat value, if this potentiometer variable resistor, let's call it as a variable resistor. If this resistor value is 100%, that means I have 100% of water in my tank. But for the 100%, all the LEDs has to be stable. So they are not being stable, they are just flickering. That is because the filter is not doing its work properly. It has to do for this inductor, for this filter to do its to do its function properly, you have to keep these values. So that is 27 microhenry and 300 microfarads. Okay. So this is 300 microfarads and this is 27 microhenry. Now, if I run the simulation, I have 100% of water, and this is taking some time. Okay, that's 0%. If I do 20%, so for 20% also, only one LED. So if it is just above 20%, so the second LED is glowing. Okay. Now this is somewhere between 20 to 40. So up to 40 volts, up to 40 volts. Sorry, I'm not able to show you this. Let me do one thing. No, if I zoom it there, so I need this whole part up to here. Okay. So just observe the value here. Let me try to zoom it some more. Yeah, now the value is clear. So if it was below 20, if I go 19%, so this LED is going to turn off. So only one LED is going to be on. Okay. As soon as I touch 21%, this is going to turn on. And if I go on like this up to 40%, the third LED D3 is not going to turn on. Okay. Up to 39 and up to 40%. As soon as I hit 41%, the D3 is going to turn on. Now, from this 40 to 60%. So this is 59, D4 is turned off. When I hit 60, it's about to turn on, but the voltage is not sufficient, or the animation is not, the animation is very quick, so it's not able to show. It's not able to decide whether you should turn on or you should off, because we have defined the condition only greater than 60, greater than or equal to 60. Okay, but it's not able to. Okay, yeah, this condition. We have not defined this condition. We have said that it should be greater than 40 or equal to 40 and less than 60. Okay, in that case, the third LED had should turn on. We have not defined of the condition for equal to 60. Okay, that's why it's flickering. And for this, when I go for 61, D4 will turn on. In the same way, when I go for 80, 75, 76, 77, 78, 79, 80. So D5 is not turning on. When I get 81% of water, or the sensor is able to sense 81% of water, D5 will be turned on. And similarly, when I go for 91%, so D6 is turned on up to 100%. Okay. So that's the complete circuit and working of our water level sensor. Hope you have understood this, and that's it in this video. See you in the next video. Thank you.